Okay, next gas law. So the next gas law is Avogadro's law. Now, unlike the other laws like Boyle's law, Charles's law, and Gay-Lussac's law, this law was not discovered by Amedeo. It was just named after him because this takes a look at the number of particles versus the volume of a gas. Now, since the number of particles is counted using a convenient method of bulk counting, which is the mole, and the mole's number is the number associated with one mole, which is Avogadro's number, was discovered by Amedeo Avogadro. So, sorry, not Amedeo Avogadro. So it was named after him, but this was never really discovered by him. But anyways, let's take a look at this law. Now, to think about this law, think about blowing air into a balloon, right? So at first, your balloon is not yet filled up with air. So you blow air onto it. So what are you doing when you're blowing air into it? You're adding particles inside the balloons. So if you add the number of particles, and this number of particles, just for ease of discussion, we'll just represent it with N, which is the number of moles, right? So if you increase the number of moles inside a container of a gas, then the volume would expand. So the volume actually expands. And if you have a fully filled balloon, it's a balloon full of air, and then you let go of air a little bit, right? Such that you are removing some of the particles inside that balloon, then you know that the volume will also decrease, right? So just like that, you can see this increases, that increases, this decreases, that decreases. So therefore, the relationship between the number of particles, which is counted in moles, and the volume is direct proportional 1. So the relationship is they are directly proportional. So similar to the other laws, and therefore if this and that are directly proportional, so you can divide 2 and get a constant. That means that you can look at two states of a gas and you can equate them like that. So if V and N is a constant, and V and N is a constant, then the first state and the second state can be equated because both of them equal a constant. So just like before, we will solve a sample problem for this one. So if, say for example, a word problem, and I'm just going to, not write the whole word problem, just given. So say, let's say a balloon is filled up with 30 moles of oxygen gas, such that it gets inflated to a volume of 50 or 30 moles of an unknown gas, right? Such that it inflates, the volume inflates to a volume of 1 liter, right? So the question is, if I were to add more number of moles such that my target is the volume will inflate to, say, 1.5 liters, the question is, how many particles should be in that state such that my volume would inflate to 1.5 liters. So again, just like that, just like before, you just take a look at the equation and say, hey, I'm solving for N2. Manipulating this, that means N2 is just V2 divided by V1 times N1. So V2 would be 1.5 liters times N1 would be 30 moles, right? Divided by V1, which would be 1 liter. And so your N2 would then be 1.5 times 30 divided by 1 liter. The liter cancel each other out. And therefore, that gives you 45 moles. Right? So that is the mathematical side of the law. But from the perspective of your conceptual understanding, very simple. You blow in more particles into a container. If the container is allowed to expand, like a balloon, it will expand. So more particles means larger volume. If you take away some of the particles inside, let go of the air inside of the balloon, that balloon will deflate. Its volume will decrease. And that's the essence of Avogadro's law.